Everybody, I finished grading test number 9 and I also entered the grade. Unfortunately, not everybody got 100 in the test, but do not panic because I'm going to give you a Christmas gift. If you get 100 in test number 10, then you get 100 in test number 7, test number 8 and test number 9. I call it Christmas gift. Now, I'm going to go over the test number 9. Test number 10, I'm going to make it just like test number 9, right? I'm going to only change the values. This is my Christmas promise to you. I have a 10 kilogram box, right? And I have mu s, which is 0.3, and mu k, which is 0.2. Now you apply, all right, you apply some forces, 29.3 Newton. What is the maximum? What is the maximum static friction possible, right? Maximum static friction possible. Well, maximum static friction possible is mu s Fn, right? So what is mu s? Mu s is 0.3, and Fn, okay, let's find the Fn. So this is 10 kilogram. So this is Fg. Fg is Newton's second law, mg. So m is 10 kilogram and g is 9.8 meter per second squared, right? So then Fg should be what? Fg should be 98 Newton, right? So Fn is also 98 Newton. All right, so I have 98 Newton, 29.4 Newton. Okay, so this is the maximum force of friction possible for this problem. At rest, right? If you apply 1 Newton, right, force of friction if you apply 1 Newton, force of friction become 1 Newton. If you apply 20 Newton, force of friction become 20 Newton. If you apply, right, I don't know, 29.3 Newton, force of friction become 29.3 Newton. If you apply 30 Newton, force of friction become 19.6. Why is that? Because this is a greater than maximum friction possible. Okay, so please understand this problem. This is very important. This was problem number 1. So problem number 2 has something to do with problem number 1 as well. So this is 10 kilogram, right? This is mu s is 0.3 and mu k is 0.2, right? And you apply, all right? So you see that maximum friction possible is 0.3 times Fg is 98 Newton, and Fn is also 98 Newton. So this is 98 Newton. So 9.4 Newton. Okay. So when you apply, this is location 1, this is location 2, 3, and 4. This is Fa. This is Ff. When you apply, this is how much? This is 29.4 Newton. Okay. So if you apply 29.4 Newton, what happened? Okay, a little bit more than 29.4 0.0000000001. Then what happened? Then is become kinetic friction. Fk. This is no longer Fs. Then this is Fs. This is Fs. Okay, good. Then it becomes Fk. Now, if you apply exactly 29.4, then it's constant velocity, because this is almost 29.4. So this is because this is 29.4. So 29.4 minus 29.4. So net force is 0. Net force is 0. Acceleration is 0. So therefore, it's constant velocity. So therefore, Newton first law said that what? Net force is 0. Therefore, acceleration is 0. Equilibrium. Okay, so when your applied force is equal to max force, Fs max, then the object is in constant velocity by definition. Okay, that was problem number 2. Okay, constant velocity. This mu s is 0.3 and mu k is 0.2, right? And Fg is 98 Newton and Fn is 98 Newton. Fs max is 29.4 Newton and Fk 6. So this is 19.6 Newton. Okay, so you have, this is your Fs, so this is your Fa, this is your Ff, this is your Fs, this is your Fk, right? Now this is your 29.4, okay, Newton. Now you apply 40 Newton. Applied force is 10 kilogram. Applied force is 40 Newton, right? And 40 Newton is bigger than maximum friction possible, right? 29.4. Therefore, static friction will become a kinetic friction, right? So the kinetic friction would be how much? 19.6. So now let's see. You have a box, so 10 kilogram, right? Applied force is 40 Newton, and friction has to be now 19.6, right? Because of that reason. So we have to find acceleration. So acceleration is F is equal to ma, right? So Fa minus Ff is equal to m. M is how much? 10. Okay, and acceleration is that's what we are trying to find, right? So Fa is how much? Fa is 40 minus 19.6 is equal to 10a, right? So 2.04 meter per second square. That's the acceleration. Hopefully you understand this problem. Next problem is like 80 kilogram skier slide on a wax ski on the snow, right? So 80 kilogram, or constant velocity, by the way, with constant velocity. With constant velocity, right? Okay, with a constant velocity. What does that mean? So we have a mu s, which is 0.14 on the snow, right? Wax ski on snow, and mu k is 0.05, right? Okay, so constant velocity, if he was at rest, then we have to use mu s, but he is moving with constant velocity, so 0.05, that's what we do. Skier, right? So we're going to use 10, acceleration due to gravity. So m is 80 times 10, which is 800 Newton. So Fn has to be also 800 Newton. So this is Fk, right? Fk is mu k Fn times 800, and that is 40 Newton, right? Okay, Fk, which is 40 Newton, and this is Fs. This is Fs, which is 112 Newton, right? Okay, so this is rest. This is constant velocity. This is acceleration, constant acceleration. Okay. Law of gravity, also known as inverse square law. And how the inverse square law looks like: Fg is equal to G m small m big M over r squared. R is the distance between these two mass. And now I have two body, 50 kilogram, right? And then I have 70 kilogram, and the distance between them is of course 2 meters. And I want you to find Fg. So what is it? Fg is equal to, of course, G is 6 point Newton constant, 7 times 10 raised to negative 11 times 50 times 70 divided by 4, right? 2 goes to 4 twice, and 2 goes to 70 35 times. 2 goes to 50 25 times. So I have Fg, which is 6.67 times 25 times 35 times 10 raised to negative 11 Newton. So I have Fg is approximately 5 times 10 raised to negative 8 Newton. Okay. 15 meter per second, right, at 60 degrees. I want to find the vertical, horizontal, and vertical component. Vertical component. Horizontal component has a name x. Vertical component also has a name y, right? Okay. Sometimes we call vx. Sometimes we call vy. It doesn't matter what you call. All right. So you're gonna write 15 cosine 60. This is the horizontal one, and this is the vertical one. 15 sine 60. 15 cosine 60 is 7. So 13 Newton. Okay. 20 Newton, and B is 20 Newton, right? And there is 170 Newton, 170 degree, right? I wanted to find the resultant. Okay. To find the resultant, what are you going to do? You're going to use the trigonometry. So you have two forces acting on the same point. Okay, so you draw that point, and you're going to write two forces. What are the two forces? A and B, right? What is A? A is AX, and AY, and BX, and BY. What is AX? AX is 20 cosine 0, 20 sine 0, right? 20 cosine 170 and 20 sine 170. Okay, so this one is 20, this one is of course 0, 3.5. So Rx is 0, this is your Ry is 3.5. So R is square root of Rx square, which is 0 square, plus square root of 3.5 square. So R is 3.5 square root cancel, so R is 3.5 Newton. Okay, so that is question number 7. Now we're going to do question number 8. Red vector, right? Vector A, which is 6 Newton, and this is 60 degree, right? Let's call this is vector B. This is called blue vector. Blue vector is also 6 Newton. Okay, and this is 90 degree. Okay, now what we need to find? We need to find the resultant vector. To find the resultant vector, we have to put this one on top of here, right here. Okay, so this 60 now I'm going to go over there, right? Okay, so then make the 60 smaller. Okay, so it fits. So then this has a the x component, right? And this has a y component. So this is then 30, right? And this is then 90. Okay. Then if this one is 2x is equal to 6, so x is equal to, of course, 3, right? Okay, good. Now, then opposite to 30 has to be 3. Opposite to 60 is 3 root 3, 5.2. Okay, now I have my y-axis, the y component of the red vector. So y component of the red vector, I'm going to take the y component of the red vector. This is the y component of the red vector. I'm going to put it on the, I'm going to bring it over here. This is, I'm going to call AY. And this is, I'm going to call BY. This is, I'm going to call BY, right? This is, I'm going to call BY. Okay. AY plus BY has to be, this is, AY is 5.2 and BY is 6. So 5.2 and 6 is 11.2. 11.2. Okay, so this is our y. Y is 11.2. Now let's see the x. Bx is 0. Bx is 0, as you see that. Bx is 0. However, Ax, this is my Ax. Okay, Ax is 3. Ax is 3. So 3 plus 0 is x is 3. X is 3. All right. So y is 11.2. X is 3. So what do you get? You get. Let's see. What do you get? I'm gonna bring this one over here. Okay. And this is what you get. The resultant. Let's see. I'm gonna try with yellow. This is head, and this is head, and this one is tail. So I'm gonna put it over here, and this is the resultant. Okay, this is the resultant. So what angle we are looking for? We are looking for above the horizontal. Above the horizontal. This is the angle we're looking for, right? So the resultant is above this. Okay, so tangent inverse is y over x. So tangent inverse is y is 11.2, x is 3. So this is 75 degree. So this resultant is 75 degree. Okay, so you can use the protractor to also see whether it is 75 degree or not. And that takes us to problem number 9. So the definition I gave you about the period, period is time over cycle over number of cycle, and the frequency is number of cycle. Do you see that I thought you would be able to discover the relationship. The relationship is the inverse. See, the time is on the top over here and the time is on the bottom over here. So it's inverse. So what does that mean? The period is 1 over frequency and frequency is 1 over period, right? Okay, now I have a frequency given. I want to find the period. So I'm going to find the t and I'm going to bring this formula, right? And I'm going to put the equal sign over here. So t is 1 over 5 times 10 raised to what? 10 hertz. Okay, so I have 1 over 5 times 10 raised to negative 10 second, right? Sec times 10 raised to negative 10 second. What does that mean? I'm going to convert it to the scientific notation. I'm going to make it bigger, so I have to make it smaller. So this is the answer. But in the future, I'm going to give you the period and frequency problem. Hopefully, you'll be able to find it. 10, I gave you a displacement, again vector, and the displacement vector is 20 meters. Problem number 10, I gave you displacement vector, and this is 20 meters, right? And the displacement vector has two components, the dx component and dy component, right? And they are perpendicular with each other. So I don't care which one you want to make perpendicular. Maybe you want to make this one here and this one here. Doesn't really matter. Doesn't really matter. And the displacement vector should be right here in the middle, right? Right here in the middle. So this is a displacement vector. This is dx and dy. So when let's do the head and tail. Let's see, I say dx. Let's take the dx. Let's take the dx and let's bring the dx over here. Let's bring the dx over here. All right. I have the head of the dx, and let's put the dy. Let's put the dy over here. The tail of dy on the head of dx, right? And let's put the resultant vector over here. So what do you see? You see a Pythagorean theorem, right? And making it obvious, right? So the dx should be what two component? It doesn't matter. So and let's see, 12 and 16 work. 12 and 16. So then this is c squared, right? So c is square 12x squared, 12 squared plus 16 squared, right? So c hopefully gonna give you 20. 12 squared plus 12 square plus 16 square, and that gives you 20. Yep, 20. So this is 20 meter, right? So this is how you're going to do it, right? I'm going to put them back. So this is dy, this is dx. They are perpendicular to each other, right? This is 20, this is 12, this is 16. This can be 16 too, and this is the resultant. All right, okay, and that was problem number 10. Now we're going to do problem 11. You are driving, right? You are driving on the road. Okay. All right. From west to the east. From west to the east. Okay. And you are driving with velocity, constant velocity, 29 meters per second. Okay. And you see Mr. Body somewhere here, right? You see Mr. Body somewhere over here, right? Who is 60 meters away crossing the road. And what is your immediate reaction? Your immediate reaction is hit the brake, right? However, since you have a reaction time, okay, you're not gonna hit the brake instantaneously, right? It depends on your reaction time. How do you find your reaction time? Okay, you find your reaction time here, 5 centimeter, right? You drop, you put your finger over here, right? You put your finger over here, and you hold it, and it's 5 centimeter. So that's how you're going to find your reaction time. So let's first find your reaction time. Your reaction time is half AT squared is equal to D, right? So AT squared is equal to 2D, right? So T squared is equal to 2D over A, which is 10. So T squared is equal to 2D is 0.05 over 10, right? So T is equal to 0.1 second. That's your reaction time. Your reaction time is not that bad, right? Your reaction time is very good. However, it's not zero. Your reaction time is not zero. Hopefully, you'll be able to save Mr. Body. Now, okay, good. So this is location 1, this is location 2, and this is, I don't know, location 3 you're going to find. Where is location 3? From here to here is 60 meters, right? Hopefully, you should be able to stop right here, maybe 59 meters, maybe 60 meters, then it's still fine. But if you pass this line, if you pass this red line, then that would be bad. That would be bad. Okay. Anything more than 60 is bad. 61 is bad, 62 is bad, 63 is bad, and so on. Good. Now, from here to here is constant velocity. Constant velocity. Why is that? Because you did not hit the brake. Since you did not hit the brake, acceleration is 0. From here to here, right here, you hit the brake. You hit the brake right here. Hit the brake. Hit the brake. You hit the brake right there at location 2. So the velocity will no longer be 29. So velocity would be decreasing, right? Would be decreasing, decreasing, and so on. It's going to come to 0. So what does that mean? If the velocity is this direction, this is, by the way, this is velocity vector, velocity vector, velocity vector, velocity vector. So acceleration must be to the other direction, right? If they are same direction, then you speed up. If they are opposite direction, that means you slow down. Here you're slowing down. Why are you slowing down? You hit the brake. Why you hit the brake? To save Mr. Body. Okay, good. Now, then this must be to the west, acceleration must be to the west, so acceleration is, you can write negative 6 meters per second square. I was going to write positive because the arrow is there. I don't want negative twice, but just to over emphasis, just to put over emphasis, I put the negative sign over there, 6 meters per second. Now, hopefully, at some point, somewhere your final velocity is 0, and hopefully that's this point. If your final velocity is 0 over here, then you are stopping, but that's help nobody. Okay, so your hope is, hey, your final velocity is 0 over here. Okay, so BF squared is equal to VI squared plus 280. Your final velocity is 0, right? VI squared is 29 squared plus 2 negative what? Negative 6 D. You are trying to find D. So D is 29 square and 12. 29 square divided by 12 is, I believe, 70. 29 square divided by 12 is 70. So D is 70. All right. So, so this is, you hit the brake over here. You hit the brake over here, right? So from here, okay, from here to here is, I forgot to do that one. Let's see from here to here. And here to here is, D is VT. So from here to here, how far you move? All right, before you hit the brake. So D is, V is of course 29 and T is 0.1. So that is 3. Okay, after 3 meter moving with constant velocity, after 3 meter, you hit the brake. And after 70 meter, from where you hit the brake, you stop. Your final velocity is 0. Where is final velocity 0? D is 73 meter. At 73 meter from here, your final velocity is 0. But Mr. Body is at 60 meter from here. So you did not say Mr. Body. Okay, but you try. 305 degree. All right. So what is A plus B? Okay, let's see whether we understand what is 305 degree means. To understand this, we have to put B on XY coordinate. If I put it on XY coordinate, what does that mean? That means from here to here is 305 degree. That's what it means. Okay, good. Now we want to find the size of this one. Not size of this one, we want to find the size of the resultant. Okay, so if we put it like that, that would be wrong. You're going to put it like that, right? Okay, so you're going to find the resultant, and we want to find the size of this resultant. Okay, good. The size of the resultant would be, let's see. Okay, so you have V vector, how many? 2, A and B. A has AX and AY, B has BX and BY. So A is of course 10 cosine 90, 10 sine 90. This is 12 cosine 305. This is 12 sine 305. Okay. This is 0. This is 10. Negative 9.8. All right. So what is your X? Your X should be 7. What is your Y? Your Y would be 0.2. All right. So what is your R? Your R is 7 square plus 0.2 square. R is 7. So this is your R. And R is how much? 7 Newton. That is your resultant. B is X Newton, and resultant is 3.5 Newton. I gave you how many? Okay. Which one is the answer? Let's see. Let's find the max and mean. I'm going to put 20 Newton over here. I'm going to put 20 Newton over here, 20 Newton over here, 20 Newton over here, 20 Newton over here. And I'm going to, of course, write max and mean, right? I'm going to write max. I'm going to write max to mean. Max to mean. Max to mean. Max to mean, right? Of course. So the max would be 22. All right. Let's use different color. 22 to 18. Right. That's the max to mean. Max would be 25 to 15. Max would be 30 to 10, and max would be 40 to 0. Right. Where does 3.5? Is there any 3.5 possible? No. This is, okay, let's put this degree. This is 0 degree. This is 180 degree, right? This is 0 degree. This is 180 degree. This is 0 degree. This is 180 degree. This is 0 degree, this is 180 degree, right? Okay, what does that mean? That means vector 2, 0 degree means vector 2 and 20, 2 and 20 are at the same direction. And 180 degree means vector 2 and vector 1 and 2 are the different direction. Two vectors are the same direction and two vectors are at the different direction. That's what 180 80 means. Two vector 0 means two vectors at the same direction. That's why you have max. Two vectors are different direction. That's why you have a mean. Two vectors at the same direction. That's why you have max. Two vectors at the different direction. That's why you have a mean. Right? Good. Now, do you have 3.5 in this range? In this range, do you have 3.5 possible? No. This range, do you have 3.5 possible? No. In this range, do you have 3? No. In this range, do you have a 3.5 possible? Yeah. Maybe 170 degree will give you. Maybe 170 degree will give you. Because 0 degree give you 40, right? 180 degree gives you 0, right? So maybe 170 degree give you 3.5. The 5 Newton give you 6.9 Newton. You see that 5 Newton plus 5 Newton, so you have so many possibilities. This is 0 degree, so this is 5 Newton, 5 Newton, so this is 10 Newton at 0 degree. This is 5 Newton, this is 5 Newton, this is 0 Newton, 180 degree. Let's see what about in the middle. So this is 5 Newton, right? And this is 5 Newton. This is 90 degree. And 90 degree always give you, okay, we know that. So 5 squared is 25 plus 5 squared is, so 90 degree gives you 7. 90 degree gives you 7. All right, now is 6.9. Okay. All right, so it has to be more than 90. It has to be more than 90, less than, okay. It has to be more than 90. So let's check 93. Okay, because 90 give you 7 and this is almost 7. So let's check 93. Let's check 93 degree. Okay, I have vector A, which is 5 Newton. This is 90. I'm not gonna use 90, so I'm gonna use 90. What? 93. 93. So vector B is 93. Well, vector B is also 5 Newton, and this is 93 degree. Okay, so vector A B, AX, AY, BX, BY. So A is 5 cosine 0, 5 sine 0, 5 cosine 93, 5 sine 93. So this is 5, this is 4.7, this is my x, my y is 5. So 4.7 square plus 5. All right, so 93 degree gives us 6. X, and I have y, x-axis and y-axis. So you are moving 10 meter, 10 meter, right? 10 meter. You are moving 10 meter, and then you put the x-axis, you put another x-axis over here so that you can draw 25 degree angle. 25 degree what? 25 degree southeast. So this is 25 degree. This is not 25 degree. This is 25 degree. 25 degree southeast. However, 25 degree, then you have to use negative 25 degree. So you better off using 335. 335 degree. Okay, and that is how much? Vector B is also 20 Newton. Vector B is how much? Vector B is 20 Newton. Okay, now I'm going to find, because I want to find the angle, right? Okay, I want to find the angle. What angle I want to find? I want to find the resultant angle, resultant vector. This is the size of this vector. So what is the displacement? Displacement is whatever it is. Let's find. Okay, so I have vector. I have two vector A and B, AX, AY, BX, BY. AX is of course 10 Newton, 10 cosine 90, 10 sine 90. This is 20 cosine 335, 20 sine 335. And this is 0, this is 10, negative 8. Okay, so you have x 18 and you have y 2. So you have r is 18 square plus 2 square. Question 17 is Newton's second law, of course. Question 17 is Newton's second law. Okay, so now I have 5 kilogram object. Acceleration is 6 meter per second square. Applied force and force of friction. Friction is 10 Newton. I want to find the applied force. So you know that F net is equal to ma. F net is what? F net is Fa minus Ff is equal to Mn. Fa is, of course, you try to find, Ff is 10, M is 5, acceleration is 6. So Fa minus 10 is equal to 30. So F applied is 40 Newton, right? F applied is 40 Newton. You have location A, location B, and location C. What happened at location A? Location A, you crouch your knee. Why did you crouch your knee? Or how long you crouch your knee? 0.48 meter. Why did you crouch your knee? To take off. Take off from where? Take off from the ground. When you take off, it looks like parabola. Why? At the max height. At the max height, at the max height, which is max height is 0.24 meter. Okay, you go all the way 0.24 meter. Okay, at the max height, which is 0.24 meter, velocity is 0. Okay, good. So few things we want to make sure we understand. The velocity at location A is 0. Velocity at location B, we try to find. Velocity at location C is 0. First thing we're going to try to find is the velocity at location B. We're going to find this one. So Vf squared is equal to Vi squared plus 2AD, right? Okay, so 0 square, okay, 0 square, where is the velocity at 0 square? At max height. What is the max height? 24. What is 24? Over here. Okay, I'm going to in fact put this 24 over here, so it probably better. I'll put that 24 over here, 0.24 over here. Okay, at max height, the velocity is 0. So BB, so this is called B squared plus 2 negative 10. Why negative 10? When you are in the air, all right, acceleration due to gravity, you are in free fall. So negative 10, you have acceleration, and that is negative 10. You have acceleration, that is negative 10. So VV is 2.2. Velocity here is 2.2 meter per second square. There is an acceleration here as well at location 2. So let's find the acceleration at location B. Bf square is equal to, right, Vi square plus 2AD. Now we're gonna use this too, right? Okay, at you start crouching from 0 centimeter, right? 0 centimeter. You start crouching from 0 centimeter to 48 centimeter, right? Okay. At 0 centimeter, your velocity is 0. At 48 centimeter, your velocity is 2.2. Okay, plus 2 acceleration you try to find, your crouching acceleration, that's what you try to find. How much did you crouch? 48. It all makes sense. So A is 5 meter per second square. Good. Now we try to find your net force. So this is This is I'm going to put it over here. This is Earth, all right, and this is you, and this is you, all right. This is you. I'm going to put a box instead of that's more standard. Okay, box. This is you. Now I will put them side by side. Okay, now let's find you are 200 kilogram. How much you are? You are 200 kilograms. So you are heavy. Not as heavy as Earth, but you are heavy. So 200 kilogram. What does that mean? You have weight. Weight is let's use 10. 2000 Newton, and that means the Earth. Okay, what does that mean? Which is equal in magnitude, opposite in direction. So the Earth is, what does that mean? I explained it in the class other day. Instead of weight, you can call your force. Okay, your force, the force on Earth by you. The force on Earth by you is 2000 Newton, and then you, instead of Fg, you can call the force on you by Earth is also 2000 Newton, equal in direction, equal in magnitude, opposite in direction. This is Newton third law pair. Okay, Newton third law pair. Okay, 2000, 2000, good. Another one, of course, is F. This one has to be bigger, right? So F is m g plus a, to be also equal in magnitude, opposite in direction. M is m g plus a. If you don't understand where this come from, let's see. Let's say this is you, right? This is your mg. This is your F push. Okay, who is pushing the Earth? Okay, so you write F equal ma. All the forces. What are the forces? F push minus mg is equal to ma. So F push is mg plus a. All right. Other day I derived it. I just wanted to show you on the side. Okay, so I have two vectors. I'm not going to write too much over here. So I'm going to write F. I'm just going to keep this one dark. So this is 2000. F g is 2000 Newton. And okay, so I'm going to calculate this one, the blue one. F 200 times 15, 200 times 15, and this is F 200 times 15. Okay, where 15? This is 10, and where this is 5. 5 come from here, and 10 is acceleration due to gravity. So 2000 times 200 times 15, 200 times 15, and that would be 3000. So this is 3000. F is 3000. So this is also F is 3000. Okay, good. Now I'm going to erase everything. I'm going to write F is 3000. I'm going to write F push, and I'm going to write also F push. They are pushing each other. Who push who? Mr. Body push Earth, Earth push Mr. Body. This is Earth push Mr. Body, and this is Mr. Body push Earth. Okay, now let's find, this is Earth push Body, Body push Earth. If so now let's see, let's find Mr. Body's net force. Mr. Body's net force, net force body has to be ma, right? Okay, so I have to find Mr. Body's net force, I have this one minus this one. So I have 3000 Fp minus Fg is equal to F net. So 3000 minus 2000 F net. So F net is 1000. This is Mr. Body's F net. Earth F net is also same. Earth F net is also same but different direction, negative 1000 Newton. If you do that, you do 2000 minus 3000, you're going to see 1000. So this is answer to 18, and this answer to 19 would be this. Acceleration is F net, which is negative 1000 minus 6 times 10 raised to 24. Why? This is the mass of the Earth. Okay, so you have okay, so you have acceleration is 1 over 6, negative 1 over 6, negative 1 over 6 times 10 raised to 24 minus 3. Oh, well, minus 24 plus 3. Minus 24 plus 3. So acceleration is minus 1 over 6 times 10 raised to minus 21. So 1 over 6 is 2.16 times 10 raised to negative 21, which is scientific notation 1.6 times 10 raised to negative 22 meter per second squared. So Earth is moving down with that much acceleration. Okay, now you have a long table which is 10 meter long and which is also 10 meter length. You have a marble rolling from here to here, right? Okay, and marble falls. Okay, so this marble falls. Marble will end up over here. I ask you to find impact velocity of the marble. What would be the velocity? Right here, what is the velocity? Right before it hit the ground. What is the velocity? That's what I ask you. And I told you that from here to here, this 10 meter marble takes 2 seconds. But who cares? Nobody cares. We don't care. We know velocity to Vx and Vy. Vx is, of course, distance over time, 10 over 2, which is 5 meter per second. And velocity is 0. All right, the vertical velocity is 0. We don't care about horizontal velocity, we care about vertical velocity. That's give us time. So let's find the time. D is equal to VIT plus half AT squared in the y direction, right? So this is a negative 10, and this is 0 because this is 0. 5t squared, right? Negative, negative cancel. So 2t squared is equal to 2. So t is 1.4 second. So velocity over here is Vf is equal to Vi plus At, of course, in the y direction. So this is 0, we said that. So Vf is Ay is negative 10 and 1.4. So this is velocity here, right here before hit the ground is 14 meter per second. 14 meter per second is, I don't give you close to 14. I give you 20. 20 is the closest. So that's the answer. All right. And the test, I already upload the practice test, right? Practice test, not practice test. This is going to be the test 10. Everything going to be the same. One problem number 20 would be inclined plane. So inclined plane, you're going to cover it on. I'm going to assign you some homework. This is the inclined plane. Okay. So you put a box on the incline, right? Okay. So this box will roll because this is an incline. So how can you find the formula? I'm going to quickly give you the formula to find the acceleration. So the gravity has two components. This is mg. This is called perpendicular component of the gravity, and the perpendicular component of the gravity has another name. Well, this one is called perpendicular. This is F normal, and this is called FG parallel, and this is of course FF. Okay, FF is mu Fn. FG is mg cosine theta. This is mg sine theta. So, to long story short, acceleration is what? Acceleration is F net over mass. Okay, so what is acceleration? F net? F net is, you have F equal ma. Let's start from F equal ma. F equal ma. How many forces? You have Fg parallel, minus Ff is equal to ma. So you have mg sine theta minus mu Fn. Fn is, this is Fn. This is Fn. Fn is mg cosine theta. Mu mg cosine theta is equal to ma. Mass doesn't matter. Mass cancel. Mass cancel. Okay, so what do we get with? We have g sine theta minus mu g cosine theta is equal to acceleration. All right. If there is friction, the formula is g sine theta minus mu cosine theta, mu g cosine theta. This is the acceleration. And if no friction, then acceleration is g sine theta. Okay, so I'm going to show you two examples. Okay, all right. What is the acceleration? A 10 kilogram box, 10 kg box sitting on this, right here, 10 kg box sitting right here. What is the acceleration? Acceleration is g, which is of course negative 10 sine 90 degree. Okay, so sine 90 degree is, this is sine 0 degree. Okay, z sine 0 degree. Why 0 degree? Because this is 0, which is 0. Acceleration is 0 over here. But if you put over here, this is say frictionless. If you put this one over here, this box 10 kilogram, right? Then acceleration would, this one would be, this is sliding this way, acceleration would be negative 10 sine, let's give you 30 degree. So negative 10 sine 30, and that is 5 meter per second square. Okay, now if you do friction, let's say you have a friction over here, mu k is 0.3, then what is the acceleration? Acceleration is negative 10 sine 30 minus mu f mu g cosine theta. So this is, you already know, 5 minus 0.3, g is 10. We already put the negative, so you don't have to worry about that. And cosine 30. 0.3 times 10 times cosine 30, and that is 2.6. 5 minus 2.6 and minus 5, and that is 2.4. Okay, all right, so what does that mean? 10 kilogram acceleration is 0. 10 kilogram no friction, acceleration is 5. 10 kilogram friction is, let's say mu k is 0.3, acceleration is 2.4. meter per second square. Pretty easy. And probably I'm going to give you this problem, this one, friction. And that's it. I'll see you. I'll see everybody Monday.